Right, morning gents. I am giving this a go, teaching on my sister-in-law's fancy iPad and going to try to record the answers to exercise 1. Trig compound angles, let's give it a go. I've taken a photo of the question paper, so I'm going to work through it with you. You've already got the memo, but let's go through it anyway. I'm just going to show you my thoughts as we go through this worksheet, just to show you basically what we're going to have to do. Right, compound angles, as you have hopefully seen, the proof's pretty rough. Don't worry too much about the proof. But there are 5 compound angles. There are 2 cos ones. Cos A minus B is equal to cos A times cos B plus sin A times sin B. You've got 5 of them, okay? The base one, the first one, was cos alpha minus beta or A minus B, whatever. Then after that, we've got the cos A plus B. You got your sin A minus B and your sin A plus B. Those are the 4 most common ones. You've also got your tan A plus B, which is the 5th one that I've labeled number 5, but it's not very popular. But anyway, you've got 5 examples that I gave you also, or that I showed you how they work. And then, yeah, this exercise. So let's see what we're going to do about it. Right, so this is a sin A minus B one. So if we expand that, we know that there's going to be sin A cos 45. And then the sine, remember with the sine compound angles, that sign over there follows. So you're going to have a minus there. Now cos gets a chance to be cos A, and then you've got sine 45 over there. Okay, whenever I see the numbers 30, 45, or 60, you should know that those are what? Those are your special angles, or special triangles rather. So when you've got a 45, you should know that that's 45, 45, 90, 1, 1, and root 2. So that guy there and that guy there can be replaced with their special angles. So cos is adjacent over hypotenuse, so you've got 1 over root 2. Nothing I can do with cos A, so that's just going to stay. Sin A is also going to be 1 over root 2. Okay, so at this stage we can't subtract them because they're unlike terms. So what we could do to make our answer slightly more simple is we take out an HCF of 1 over root 2 and you're left with sin A minus cos A. Okay, so there's the first little example of a compound angle in action. Going to go to number 1.2, which was that guy, cos beta plus 30. So much the same thing, and this is where you're going to get better and better at expanding these. 30 obviously we know is a special angle, so that's going to come in handy. If I expand that, it's going to be cos B cos 30. Okay, the cos law, cos. This sign, because it's a plus, this guy has to be a minus. The cos laws, it's opposite way around. Now sin beta sin 30, and then once again the 30s are going to have a chance to get substituted out. So cos beta, nothing I can do there. Your 30 and 60 are part of a special triangle that looks like this. 1, 2, square root 3. So now cos 30 would be, you can substitute that as root 3 over 2. Do you see it there? I'm in that corner, adjacent over hypotenuse. Minus sin beta, can't do much there, and sin 30 was what? A half. Right, so what you could do, I guess, is you could take out an HCF if you want to. I know my memo takes it a step further and says a half, take that out, and I'm left with root 3 cos B minus sin B. So you can do that. It's not achieving too much, but yeah. 1.3, let's have a look. Sin P plus P, pretty chilled. Sin P plus P, you're going to expand that, so that's going to be sin P cos P. Remember, your sign's the same. And now it's going to be cos P sin P. Okay, because those are exactly the same, they're like terms, you can add them together to give you 2 of cos P sin P. I probably could have erased that. Let's see. Erase Oshi, what a beast. Okay, so there's 1.3 done. 1.4, the last one in number 1's here. You've got cos of, I think it was x minus 2y. So cos rule, so it's going to be cos x sine 2y. Ah, man, you see what I've done now. Let's try that there. Okay, back on board. Okay, cos x times cos 2y. Your sign's different, it's the opposite, plus sine x sine 2y. Is there anything I can do there? No, I'm done. So 1.4 is done. Looking at number 2's, you see this was an expansion question. Now we're reducing something back into the compound rule. So 2.1, they give you the question cos 3b, cos 2b, plus sine 3b, sine 2b. So what do you notice? This is definitely going to be a cos rule. Why? Cos, sine, sine. So definitely a cos rule. Also, you notice this is a plus. So the sign that you're going to have in your answer is going to be a minus, because the cos rule has the flip. It's the opposite. So what do you also notice? This is a 3, this is a 2, this is a 3b, this is a 2b. So your pattern is working. So if I had to now reduce it, it's going to be the cos rule. It's going to be something minus something, and it's going to be our first angle there minus the second one there. So it's going to be 3b minus 2b. Okay, I can obviously take that one step further, which is going to be cos beta. Happy? Number 2.2, I'm not going to go back up. I've got a question paper next to me. Sine 5a cos 4a minus cos 5a sine 4a. Okay, so once again, you should be thinking, what type of compound angle is it? I'd say it's a sine one, because it's got sine, cos, sine. Right? You remember the sine? If there is a minus there, you're going to have a minus in your question. It's the same. And here you're going to have 5a minus 4a, so this answer ends up being sine a. Cool? 2.3, let's see if it steps it up here. I'm not sure. So sine 10, cos 10, no, it's not 10, it's 20. Sine 20, cos 10, plus cos 20 and sine 10. Are there any tricks here? What rule? Sine, cos, what do you think? It's going to be a sine rule because they alternate there. So you're going to have sine. Is our sine going to be a plus or a minus? It's going to be a plus. And you've got 20, 10. Why can I go into it straight away? 20, 10, 20, 10. So I'm ready to use my rule. Sine 20 plus 10 is going to give you sine 30, which we can take further using special angles, is a half. Okay. 2.4 is where it maybe gives you a little bit more work to do. So let me write the question out first. Cos 20, cos 80, plus sine 200. And a sine 100. Okay, so straight away you can check for yourself. Cos, sine, sine. Great. So it looks like it's going to be a cos rule. Okay, but the problem comes in that you've got a 200 and a 10 and a 100 there. You don't have your 20, 80, 20, 80 pattern. You've got a 20, 80, 200 and 100. So I'm going to have to somehow change this to get the pattern working. So there are ways to do it, and there's probably an alternative that some of you might have gone with. Is I'm going to change the 200 into a 180 plus 20, and I'm going to change the 100 into a sine of 180 minus 80, right? 180 plus, 180 minus are reduction formula, which you would have done in grade 11. So once again, the cos 20, cos 80 is doing nothing, but now 180 plus, remember we're in our quadrants, the cost diagram. 180 plus is going from there and you're going into the third quadrant. So that is not sine's quadrant, it's tan's quadrant. So that there reduces to negative sine 20, right? So your plus there has changed to a minus over there. Okay, and then the last piece, sine 180 minus 80, you're over there and you're going into sine's quadrant. So that becomes sine of 80. Cool, reduction formula. So now we've got what? Cos, sine, sine, and we've got a 2080, 2080. So we're going to be cos compound angle. If this is a plus, if this is a minus, this is going to be a plus, and we got 20 and we got 80, okay, which is going to give us our answer of cos 100. Cool. I'm going to stop this video and send you a few more.